So graphing the sine curve or graphing the sine wave, sine curve, sine wave, either way, but the technical name for it is actually sine wave because it's going to look like a wave when we graph it. But the first thing I want to talk about is this note, which is certain functions with a repeating pattern are called periodic functions, or meaning they have a period. So a good example of it is going to be this function. All right, so this function here is said to have a period. Reason why is it's a pattern that constantly repeats. All right, it's a pattern that goes over and over. If I chose to start this pattern right here at -4, the pattern ends right here at -2. So that's the entire period of this function. Everything else is just a copy of it. It's just a Xerox copy of the previous one. So this is one period of that function. So that's why it's called periodic. It's a function that constantly gives you the same image over and over again. And the period is going to be the length that it takes to begin and end. So it begins here, ends there, to sort of find that length there. Typically find the length in the coordinate plane, you start at the right and you subtract backwards. So I would say -2 subtract -4. So you start there, you have -2 subtract -4, that's really -2 plus 4. So that outputs 2. So I know my period is 2. That's how long that is. So that period is 2 units long. So that's the period of that function. That's what a periodic function looks like. It actually it just constantly repeats itself over and over. I'll give you another example. So here's another example of a periodic function. And the question is, well, the question is, what is the period of the function? So it's periodic because if you notice, it's the same pattern. It just constantly goes the same way. And this actually looks a lot like a sine wave. We're going to graph in a minute. But this is what it looks like. So you choose a point to say that began at. I mean, you may choose any point to say that's the beginning of that period. And you look for where it ends. So if we look at this function, it basically starts here at 0, basically. So if it starts there at 0, we're looking for when the pattern starts to do the same thing. So it goes up, goes down, comes here, and then it goes up again. So it got back to this level all over again, right there. So that was the entire period of it. Afterwards, this section, that section is just a repeat of this section. So we don't really need that. We're looking for one period of it, and it would start here, and it would end there. So it's kind of easy to count this one off. It's at 1, it's 2, and it's 3, and it's 4. But just for good measure, just so we understand how to find the distance in the coordinate plane, or distance on the number line, rather. So distance on the number line, you start at the right, subtract backwards. So we'll say 4, subtract 0, but that's 4. So I know my period is 4. All right, and that's how you find a period at any curve. You look for where it begins, and someone else may have chosen to begin here. Where it began there, you look for when it actually does the exact same thing all over again. Well, that means it would end there. So because afterwards it starts to do the same thing again. So this would be one period. It would start here, end there, and that would be your period. But you'll find that if that's the case, you start here at -1, and then you subtract it backwards. So subtract a -5. Well, -1 plus 5 still gives you 4. So either way, you still have a period for it. So right now in this problem, take a minute, pause the video right now, and answer the question. The question is, what's the period of this function? So right now, go ahead and pause the video. So if you found the period of this function was 3, you're right. And the reason why, if you chose to start here, this function goes up, goes over, goes down, goes up, goes over, goes down, and it repeats over and over. So it's started repeating itself right there. So this is our beginning, this is the end. So this function, to find the length here, it would be 4 subtract 1, which is 3. So that's the period of this function, 3. So graph from sine of theta. So the graph sine of theta it's going to be a good idea to start off with this unit circle and everything that we know about it, all these points or whatever. And so if I actually could start graphing anything that I didn't know how to graph, you probably start off with graphing the table. I'll start off graphing the table. And ordinarily you have an XY table. This time instead of an XY, we have a theta Y. Because if you remember, cosine was X, sine was always Y. So in all these coordinates, the sine value is the Y value. So what we're comparing is theta and sine. So if theta was at 0, theta was 0 degrees, well, what would sine be at that place? Well, sine would be 0. So when theta is 0, sine is 0. And then you could choose any of these other angles. I'm going to go to the next one though. I won't choose just 4 of them. We'll talk about numbers in between later. But if theta was 90, sine would be 1. So when theta is 90 degrees, and that's 0 degrees, sine would be 1. And if theta was, say, 180 degrees, sine would be 0. So when theta is 180 degrees, sine is 0 degrees. Oh, sine is 0. It's a limit. You want to need a symbol there. And the last one would be, or next one would be, if say theta was 270, theta was there, sine would be right here at -1. And then, if theta was, instead of being 0, say theta was 360 degrees. Now sine is 0 again. So at 360 degrees, sine would be 0. And if I want to keep going, we'd see that, well, what would theta be at, if I added 360 and added 90 more to it, well, that would be 450 right here. Well, sine at 450 would be 1. So if I wanted to keep going, sine at 450 degrees would be 1. And if I added 90 to that, that would be over here. So instead of being 180, if you added 90 to 450, that's going to be 540 degrees. So at 540, you get 0. We have enough, though, to actually see the graph for it. So we're going to come with the graph by starting with the y-axis. This would be my y-axis, the vertical one. And instead of being x, it's going to be theta. So all the numbers along this axis where x used to be are going to be the values of theta, because we replaced x with theta. So the first number is 0. The next number is 90 degrees. And then the next number is 180 degrees. 270. 360. 450. 540. So those are the values of theta in degrees. So I've actually graphed that and used a different color to graph the other ones. So this is the y value here. So when with theta is 0, y is 0. So 0, 0 is right here. That's order pair 0, 0. When theta is 90 degrees, y is 1. So at 90 degrees, this would be 1. This would be a -1. So at 90, my order pair at 91 is right here. So this is the order pair, 90 degrees, 1. So it would be this point right there. The next place is 180. So when theta is 180, well, y is 0. So 180 and 0 is right there. So everything on that line, everything on this axis, the y value is 0. If theta is 270, output's -1. So when theta is 270, output's at -1, so that would be right here. And then when theta was 360, it's at 0. So that's here. 450, is at 1. So at 450, we wound up at 1. And then the last one, 540, it will be at 0. So if we looked at that, what we have is a little function. We actually have a curve. And basically this curve starts here, goes up, goes back down, connects these dots, and it's doing this. I could find the points in between here. If I use any of these values, I could have found those points in between there, and you would have found that it went up real smooth to that next point. And it would give you, went really smooth. I can keep making points all the way through if I checked out more points over here, the different values for a while. But that's the sine curve. And if you want to think about it being the negative angles, it would have kept going back in this direction like this. All right, so we're looking at this, we're looking for the sine curve, and that's what it looks like. All right, it's a periodic function. I mean, it just keeps going over and over and over again. And that's what we call a sine wave. That's why the definition of it is actually called the sine wave. And if you want to find the period of that, take a minute right now and you tell me what the period of it is. So you want to pause the video right now. Go ahead and pause it and tell me the period of the sine curve. And if you pause it, you might have chosen it to start here, and then went up, came back down, went up again. But if you notice right there, that's where the one period ends. So it starts here, ends there, because afterwards all of that is just repeat of what we already did there. So this is one period of the sine curve. That's what it looks like. If we want to find the cosine curve, it's actually very similar to it. It's actually a piece of the sine curve, depending on where you start. But just right now, we're just going to focus on the sine curve for today and what the period actually is. So basically, for the sine curve, actually you would start on the right, subtract back, so it would be 360, subtract 0 equals 360. So my period is 360. That's in degrees, 360 degrees. Period is also 2 pi radians. So you can either call it 360 degrees or 2 pi radians. So that's the period of the sine curve. The last thing I want to mention is the amplitude. So amplitude. All right, so basically it tells you how far and below it goes from the middle of the curve. So it's kind of like, if this is the middle line, my amplitude would be how high I went up. And it should be the same thing here. It should be the same length there. So if we went from 0 up to 1, that length there, that's at 1, so that length is 1. And if it went down 1, that length is still 1. Even though it went downward, we say that length is still 1 unit long. So our amplitude is 1 unit. So amplitude in the sine curve is a 1. And one way to always tell the amplitude is always going to be the number in front of sine. So if there's a number in front of sine, whatever that number is going to be the amplitude. In this case, there's no number there, so it's like an invisible 1 there. So I know my amplitude is that number. Another thing to remember is the amplitude is always positive. You would never say amplitude is like -1 or -3. You always call amplitude a positive number. And that's it.